Hi everyone, it's Alex here. I'm gonna do a quick demo of gRPC and show you how you can get started. So stay tuned. I'm going to assume that you already know what gRPC is, but in any case I'm going to do a recap of the advantages of gRPC. So first of all, we have efficient inter-process communication. gRPC uses a binary protocol, therefore the exchange is fast, and it uses also HTTP2 to increase the performance of the communication. It has simple and well-defined interfaces as opposed to REST, which relies on OpenAPI and Swagger. So the approach in gRPC is that you define the interface first and then goes the implementation, as opposed to traditional REST approach where the implementation comes first and then documentation follows after. So then it's strongly typed. As well, the definitions of that we use with gRPC, thanks to protocol buffers. Therefore, it eliminates a lot of the errors which are caused due to lack of typing when we compare, for example, with JSON and some other data exchange formats. So it's polyglot, is designed to work with multiple programming languages and allows you therefore to integrate your microservices in your architecture. It offers duplex streaming, basically two-way data streaming, not just simple request and response compared to traditional REST. It has built-in commodity features such as authentication, encryption, deadlines, timeouts. We're talking about resiliency, metadata, compression, load balancing, and many, many more. All of them built in. So just have to sort of enable them. It's integrated with cloud native ecosystems, and it's mature and widely adopted. Okay, it was matured and battle tested at Google, and it's in use at companies such as Square, Lyft, Netflix, Docker, Cisco, CoreOS, and etc. So let's get into it. As prerequisites, we would need to have Go installed. We would need the protocol buffer compiler installed, which will give us the proto-C command, and we would need some Go plugins as well installed. As mentioned here, the proto-C or protoc gen Go and the protoc gen Go RPC plugin, as well as the Go modules environmental variable to enable Go modules, and the basically update our path so that the proto-C compiler can find the aforementioned plugins. I will mention the link to this page in the description of the video. But in my case, I have everything already installed, so I'm going to jump straight into the code example. So here we have our gRPC quickstart code. Again, I will share the link to the GitHub repo with the code. So basically, we will have here a gRPC client. We have here a sort of package for our gRPC server. We have the proto definitions in the proto folder. We have our Docker file to dockerize the gRPC server. Go mod definition to define our module and the dependencies. We have the main Go, that is the main entry point for our gRPC service, and a README with some additional helper commands. So let's start by exploring the proto folder, which contains the service definitions. Okay, so here we have the service.proto, which is a protocol buffer definition, and following the protocol buffer syntax, we start specifying the types of messages that our gRPC client and server are going to be exchanging, as well as the interface. Okay, so in our service is called foobar service, and it will have, in this case, just one action that it can do, which is called execute. It starts with RPC keyword, the name of the action or the function called execute. It takes a parameter or multiple parameters I could have specified, in my case just a single parameter of type foo, and it will return a single parameter of type result. So therefore I need to specify the types of these parameters, types of these messages. So let's see what's the foo. How is the foo defined? So foo is a protocol buffer message with a attribute of type string called foo. Then following up, let's look at the result. So the result is as well a message. It has a attribute data, which is a one-off. It can either be an error or a successful response, and in this case of a successful response we get bar, and bar is typed a bit above. It has a attribute with the same name, bar, of type string, and our error is pretty similar as well, as a message error with an attribute message that contains the error message of type string. So that's basically our service definition. So in here we got some additional sort of parameters for the protocol buffers, as well as the compiler of grpc that is going to generate code for us. So first we got here a parameter which says the syntax is a protocol buffer version 3 type syntax. The package within the protocol buffer, basically definitions, is foobar, and when after running the grpc compiler, we will get a code which will be located under the foobar Golang package. So having said that, let's proceed by running the grpc compiler and generating some Golang code that we can later use to build our grpc server. So in the readme we find the command which we need to run, and it's a protoc command, which basically says that we want to use this service.proto, which is located under the proto folder, and generate Golang code right next to it. Basically go out in the same directory that we have the proto definition. Okay, basically defined here by source relative. And this, we have an additional parameter, which is require unimplemented servers equal to false. I would recommend that you read the documentation about this parameter. It has been added fairly recently, just to avoid some issues with forward compatibility, but I will not go too much in depth on this parameter. So let's take this command and generate the Golang code that will assist us in building our grpc server and our grpc client. So I'm just going to paste it, hit enter, and if we just refresh a bit, we can see here that the grpc compiler has generated some code, which is at first can be quite hard to understand. Even it contains some hexadecimal array in here. But the thing is, what we need to care of is just that it generates for us the structs okay, for our messages. So we will have a struct for the foo, would have a struct for bar, we would have a struct for the error, and we would have code to basically define our foo bar service. Okay, so how do we do that? Basically, I already have plugged all the code in, so let's take a look. So first, after we've generated the Golang code, we have to go in and create manually a service. Okay, so what the gRPC compiler had generated for us is the transport layer code, and what is our task is to generate on top of that the service layer or the application layer code. So this is what I have done in here. So under my package folder, I created a folder called service, standing for the service layer, and a Go file called service.go. And I manually defined a type service, a struct, and on that struct I defined the method execute, which has to follow the interface that is specified under the service.proto. So if you remember, the service.proto has a foobar service with a function execute that takes a parameter foo and returns result. So we have to implement this interface in here. So we have a method execute. Additionally to that, we are required to add in a context, okay, in here, which is might not be straightforward to understand, but we have to add in the context, and besides the context, we add in our parameters which we've specified earlier in the service.proto. So we have here a pointer to foo, and we return a pointer to the result. And all of these structs, we get them from the foobar package. So it's going to be a fairly simple service. We just log the value of the foo parameter that we got, and we just respond with a constructed result, which we construct here, construct the result. Inside of the result, we have to specify the data attribute, which is a one-off. So either it's a result error or it's a result bar. In my case, it's a result bar, and then the result bar requires the attribute bar, and then we pass in bar, and then bar has an attribute bar, which contains the string bar. So a lot of foo bars in this service. So we got our response, and we are returning the response, and nil for the error. Okay, and lastly, we have a simple constructor function just to return us a pointer to our service. So having the service, let's take a look at the entry point of our gRPC server, which is the place where we are going to be plugging in this service. And this is the place where in the main Go, we are going to be writing code to start our gRPC server. Okay, so we begin by simply listening, opening a TCP socket which listens on a port. In this case, the port I believe is canonical to use 50051. We check if there is an error, failed to listen to the port, maybe some other process is bound to this port, and then we create the gRPC server. We use the gRPC package and the function new server. This gRPC package, we import it from google.golang.org/grpc. Then we invoke the constructor of our service that we've defined. So service new service. This is basically the constructor function in here. Let's go back to the main Go. And then we call a function which was generated for us by the grpc compiler, which is located under the foobar package. And this function is basically register whatever name your service is. In my case, is the foobar service. So therefore, it generated the function register foobar service server. And we pass in as parameters, we pass in the grpc server that we've instantiated here and the implementation of our foobar service in here. And I'm stressing out that our service needs to implement the interface according to the service proto so that we can actually pass in the service to the register foobar service server. For example, if the function would be missing, let's say, a parameter, the foo parameter, in here, let me just comment it out, we would get here a warning, or actually an error, while compiling, saying that we need to implement the proper interface in here. Therefore, we have to add in the foo parameter. And if we take a look at the declaration of this function, it tells us exactly what interface do we need to be implementing. And if we follow, we have the declaration of the foobar service server interface. Therefore, we need to implement the execute function. We need to have a context, a foo parameter, a pointer to a foo struct, then a pointer, then be returning a pointer to the result alongside an error. So having all this, finally we finish by invoking the serve method of the grpc server and passing in the listener, okay, the TCP socket that we've just opened earlier. And again, we check for errors, and if we don't have errors, we can consider that our grpc server has started successfully and is listening for grpc client requests. So let's, having explained the grpc server part, before we actually go into the demo, let's actually go and take a look at the grpc client as well. So we have a client in the client folder. It's in the file client.go. So it's going to be a client that connects to the server. It sends a message and then terminates. Okay, that's going to be our simple client. So we begin by invoking the dial method of the grpc package that'll allow us to create a connection to our grpc server. We check for errors and we defer the closure of the connection to the end of the main method. Then we use a method that is given to us by the grpc compiler, which is the a function to create a new client called new foobar service client, and it needs a connection with which we've created above. Okay, next we just instantiate a context using the current background plus a timeout of 5 seconds. Okay, and we defer the canceling of the context once the main method terminates. Then we create our struct that we want to send. It's basically our message, our foo message. So it's going to be a pointer to foo, which contains an attribute foo and a value of foo. Okay. Then what we do is using the our grpc client, we invoke the function execute, okay, which again is already defined for us. We don't need to write any code for it. Okay, we invoke execute, we pass in the context which has a 5-second timeout in case the request is going to take any longer than that, is going to be automatically cancelled. And we pass in our foo pointer to the foo struct. Okay, we check for errors and we finalize by logging the response that we got from the grpc server. So let's get to the demo and see it in action. Let's go to the readme, and here we basically find all the commands in order to run everything. To run the server, we can do a simple go run main go. Okay, the server has started. Trust me on that. Then we will run our client and see if we get any responses. So let's do go run client /client go. And here's our response. We got a response, which is the success response in our case. We didn't get any errors. We got the bar struct, okay, which has a value bar. So as simple as that. Additionally, I provide also a Docker file which dockerizes the grpc server, so we can run the same setup with a dockerized grpc server. So in order to do that, we first need to build our grpc docker container, docker image, and then we will run our container. Okay, so let's build. In my case, I did it in the past, so it's fairly fast. It uses the cached layers of the image. So once it has been built, we can do a docker run, and we need to expose the ports 551 and 551 on the container itself. We hit enter, and we can assume that our grpc server is running. Then we can invoke the client once again and see if we get the bar response, which we got indeed. So that was it. I hope it was helpful. I will mention and add all the links with the documentation and the quick start and the GitHub repo down below the video, and see you on the next one. I hope you found it quite useful. Feel free to comment down below with suggestions of new videos that you would like me to do. So take care. See you on the next one.